We're going to look at problem from 5-C1, Unit 5C1. This is a horizontal projection problem. Problem 8.5. In this problem, what we're looking at is a M1A1 tank is sitting on top of a hill or a cliff, and it's firing a shell horizontally, perfectly horizontally, off of that cliff. And what we want to figure out is how high is the cliff. So if we kind of draw ourselves a little picture here, because it's a good thing to draw. And forgive my lack of drawing for the tank, but here it is. Essentially, what we have in this problem is muzzle velocity of an armor-piercing round for this tank is 1770 meters per second. So I'll just draw that in. And remember, we're firing this perfectly horizontal, so all of this velocity here is in the x direction. Okay, that's an important thing to remember. The shell is actually going to land for us 6,520 meters from the base of the cliff. So from right here where the cannon was being fired, that shell is going to go thunk. And this whole distance right here, this is delta x. This distance is 6,520 meters. Okay. Now, what we're going to do in this problem is we do in all of our projectile motion problems, setting them up, is we're going to draw the box. So we have the x direction, the y direction, and then a bunch of stuff goes in that box. We've got initial velocity, we've got final velocity, we have displacement, acceleration, and time. Whoosh, 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 whoosh. Sound effects not included with the box, but feel free to make your own. We know a few things in this problem already. We know that the initial velocity of the cannon is 1770, because we have that right here. So that just gets tossed up. Remember, this initial velocity is the same as the final velocity, because in the x direction, there's no booster rockets or anything going on here. We'll take a look at that in a second, Liv. So there's no booster rockets on here. So when we have this 1770 meters per second, that is the initial and the final. And we also happen to know the delta x. We know the delta x here is 6,520 meters. Other stuff we just always know happens to be that the acceleration in the x direction is 0. That's why this is constant in the velocity. Y direction acceleration is negative 9.8 meters per second squared. And because we're shooting this perfectly horizontal, the initial velocity in the y direction is 0. Those are just things that we happen to know for this type of problem. If we want to solve this, what we can do is we can recognize that in the x direction I have 1, 2 of my main features, velocity and displacement. I can find time, and if I find that time, I can move it over here, in which case I would then have 1, 2, 3, and I could figure out how high is that cliff. Okay, so what we can do here, in order to find out the time it takes for the cannon to, or the shell to fire this distance, we know that a displacement equals a velocity times a time. So that means that a displacement divided by a velocity equals time. The displacement in this problem was 6,520 meters divided by 1,770 meters per second. This equals the time, which is, so let's bust out a calculator real quick. 6520 divided by 1770, about 3.68 seconds. So going back up to our top here, this is 3.68. This is then 3.68. Now that I've got 1, 2, 3, I can go solve for delta x, or delta y in this case, because it's a vertical displacement. Delta y equals 1/2 g t squared. So that's going to equal 1/2 of negative 9.8 times 3.68 seconds. Don't forget the squared. If we put all that together, we get a negative 66 meters, and that just means that the shell fell 66 meters. So that just means that the height of the cliff is 66 meters tall. If you fell 66 meters, that means you're 66 meters high. And that is our answer there. Okay, so that's how we can do a problem like this. Note, we've basically got two equations. We've got this one, a horizontal motion problem, and this one's going to be in all of our projection problems in the x direction. Drew a picture, set it up, filled in the box, and worked through the math. And that basically took us to where we needed to be. That's the end of that problem. Okay, Liv, you want to see how to do number 10 in the intergalactic, right?